Hi there, how are you? Welcome to Maths for Data Science. This is Vivek. In this video, we will learn inheritance and the magic methods available in classes. Inheritance allows us to access the attributes and methods from its parent class. This is useful because we can create the subclasses and access all the functionality of the parent class. And then we can override the functionality without affecting the parent class. So far we are working with employee class. So let's say I want to be more specific here and create different type of employees. Example, I would like to create a developer, manager, or HR. So in this particular scenario, the subclass approach is very good because the first, last, and pay would be same for developer, HR, and manager. However, there might be one small change for developer where we might need one more attribute. It might be language skills the developer has, and that might be a Python, Angular, and so. So in this scenario, we can use the subclasses. So let us learn how to create a subclass. So creating a subclass is no different than the creating a class. Only minor difference you can see is after naming the class, you have to use a parenthesis and give the parent class name. Here, the employee is the parent class because we are inheriting the attributes and methods of the parent class into our class. So that's why we are mentioning the parent class name here. Here, I am just not creating any init, not creating any methods for this subclass. I'm just using the pass method. I'm doing it to show you that these all attributes and methods are inherited in development. So let me execute and show you that it really works in that. So I'm creating a two instances. So now I have created two instances, dev_1, dev_2, and these are the two user information or the employee information I have passed. Now I'm printing its pay, and I could able to see and print this thing. So here pay is an attribute which we have inherited from the parent class, this one from the parent class. So this, and we can run the parent class functions in our subclass instance. So here the full name is a part of parent class, and I'm running it, and I will get the same out. In this place, you observe that there is a not init method defined here. Still, you could able to create an instance. So generally what Python does is first it check for init in the developer class, then it goes to the parent class. So that's how the method resolution order is. Let me show you that how it looks. So you just run help on the subclass. When you execute it, you see here the method resolution order. So first it checks any method in the developer class which you are trying to access. If it does not exist, it goes to the parent class. If it does not exist, it goes to the object. And all the classes we have in the Python does inherit from this built-in object. If you scroll further down, you can see the list of the methods available in parent class. So it is inheriting all the methods available in the parent class. Same with the attributes also. If you scroll down, you can see the attribute. So we have only one attribute in the parent class, employee, that is raise amount. The same attribute is inherited in the subclass. So let us remove this pass and make the subclass more useful. So let me remove that pass and create this subclass more useful. Now I'm saying that I'm creating the init method in subclass, and I'm passing first, as the first, last, and pay would be the same. I am passing those parameters, and additional parameter which I'm passing is the language. But the tempting part would be you copy this entire init part from the parent class and paste it here. But this approach is not recommended. Plus, this will increase the size of the code and the readability reduces. Instead of that thing, if you see, the parent class already has this variable or this instance variables. So why can't we use this thing and pass the first, last, and pay into parent class and get initialize this instance variable? We can do that. There are two ways to do it. First way, we have a super method available. You run super method on the init. So super.init and pass those three parameters. So if you pass in this thing, these particular instance variable will be initialized. And there is a second way that you can say employee, which is a class dot explicitly do the init, and the first variable you pass it as a instance variable, that is self, and then you can pass these two parameters. So there are two ways to do it, the same thing, but this way is not used very often and it's not recommended. So most of the time we use only super method. So just stick to super method. There are a couple of instances where you use this particular employee.init approach. That I will let you know whenever we run into such situation. So but for time being, we will use the super method. So as we passed one more additional parameter, which is language. So let me initialize that also. So I've created an instance variable called self.lang for maintaining or containing the language. So let me run this particular code, and as we have four parameters here, and as we did changes in our init method, so we are not taking the default init method from the parent class, but now we have created the init method in the class itself, and this particular init method has four input parameters, and here we have given three. Let me add the fourth one also. Yeah, now it's done. Let me then execute and show it to you that we could able to access the instance variable specific to the developer class, and we can access the parent class instance variables also. So lang is the instance variable of the subclass only, but the first is a instance variable of the parent class. So both we can access. Now, just to give you one more example, now there is a manager who would like to maintain the list of the employees. Suppose that's a scenario. For this kind of scenario, also you can create a subclass, because if I'm saying I'm maintaining the employees list, it means it should contain the first name, last name, the first, last, and pay, and additional information. So for that thing, we can create a class called manager, and I have initialized it. So this first, last, and pay, it's a part we are inheriting this thing because we need this thing to initialize the parent class, and this is the additional parameter we are passing, which will contain the employees information. And super method we already spoke in the previous part, and here I'm checking if employees is none, then create empty list, then create a instance variable self.employees with empty list. If no, then assign the employees value to the instance variable employees. Now I have, while creating the object, I have assigned the employee information here. But suppose after doing that, now a new employee entered, and I have to enter his information also. I have to maintain his information also. Then you don't create a new object, but you can create a method which will do so. So here I've created a method which is saying I'm checking that the employee which you're passing already exists in the instance or not. If not, then append that particular employee in the list. Let me execute and let me show you how it works. Now here I'm creating an instance variable. That is done. Now I'm checking the manager information, that is email. So now we could able to access the email variable or email instance variable from the parent class. Now, as while creating the instance, I've already passed the employee information. Let me print and check whether I could able to print. So here I am adding it, and I'm creating a one more method where I'm saying let me print all the employee list. So I'm iterating through all the list elements here, and I'm printing it. So now there is only one employee, which is Kalisha. Now we can add one more employee using the add emp method, because initially we just created an instance with one employee. Now I would like to add the second employee. That you can achieve using the function or method we have created just now. But before adding this thing, I would like to show that employees contains how many employee details. So you can see this is a list, and there is only one element exist. As the inserted information is an instance, that's why you are getting this information. And now if you would like to access this particular value, this particular instance, so this is at the 0 index, I am passing 0 from now you have accessed this thing. Now you can apply any of the method or the attribute. So now I'm accessing the pay attribute. I can get that output. If I'm say full name, which is a function, full name, I'm getting that value. Now just see, when I do add here, and when I run this thing, you can see now we have two instances. One is dev_1, second is dev_2. So now we have information of two employees. Let me print it also. See, now we have to. That's fine. Now we could able to add the employees and print the list of the employees which are available. What if I would like to delete some employees? For that thing, we can create a new method in the manager subclass. It says whatever employee information you have passed, I'm checking in the employees instance variable, and if it exists, then I'm removing it from the list. So let us execute that. Now here I've shown you that we have two instances here, or two employee information, and if we print, we are getting two outputs. Let me execute it. So here, after doing the changes, I did not execute the manager subclass. Let me execute the manager subclass. I have done it. Now let me run everything, because we have created a new blueprint. Now if you see, the Kalisha R is removed. In the print emp, you can see only one employee. Here also, if you can see only one employee. And if I say run this thing, you can get the employee which is left in the list. As this particular employee is deleted, you can't see that. So this is how you can use the inheritance in your benefit. You can inherit all the attributes methods available in parent class, and after inheriting, you can change the functionality as per your requirement. So this way, you are not creating the entire blueprint again, but you are taking the components of those blueprint and creating your customized blueprint. So that's what inheritance is. Now let us learn the magic methods or dunder methods available in classes. Now let us learn some built-in methods. Some people call it as magic methods also. These methods emulate some built-in functionality in Python, and it is also how we implement the operating overloading. So let us see one example. So in this case, if you apply the plus on integer, it exhibits a different behavior. And if you apply on a string, it exhibits a different behavior. Let us see. So if you apply on an integer, it exhibits the plus, where it sums both the integers, but in string, it concatenates it. So this is how the same operator can be used based on the input objects. So let us see something with our instance variable. If I print instance variable here, you can see some output which is not human readable and it doesn't give you any information. But we can achieve that. We can achieve giving us some useful information when we print emp using these two special methods, underscore underscore rpr and string. Underscore underscore rpr, sometimes it is called dunders. If someone says dunder init, it means the particular word is surrounded with double underscores. So the very first special method we have seen was init, and this init we use to initialize as soon as the object is created. So underscore underscore repr and underscore underscore string both exhibits more or less same behavior, but there is a big difference in this underscore underscore repr. It exhibits, or it gives us unambiguous output. However, the string gives us the string out. So underscore underscore repr gives us the unambiguous output. However, the string gives us the string output. So whenever you run this print and the instance variable, first it checks for the string. If it does not exist in that particular class, then it will fall back to the repr. So it's mandate, or it's good to have the repr as a fallback every time. And if you forget to mention the string, it's still fine, but I would recommend you to mention the repr here. So here what I'm doing is whenever you print the emp, so I would like to get an output which contains the first name, the last name, np. So that's what I would like to get the output. Let me execute it and show to you. Non-string error. Let me fix this error and get back. So here I had some formatting issue, so that was the reason I was getting error. So now whenever I apply run print on the instance, I need to get this output instead of getting that gibberish. So I execute it now. See, you're getting this output which is telling that this particular class is created with these input parameters. So as I told you that if you don't declare the string special method, the fallback method is the rpr. Suppose we declare a string method, and here I am telling that when I print, the thing needs to be returned is full name and the email. So let me execute it. Now here you can clearly see that as soon as I declare the string special method, it's giving me that output. And if I don't declare it, it's falling back to this repr particular method. Now let us apply length method on the instance. So what error we are getting? We are getting that employee has no method called length. And suppose you would when you want that whenever you apply length on the employee instance, you want to get the full length of the full name. So how many characters so suppose you would like to overload this length method and says that whenever apply length on a emp1, which is an instance of the class, when I apply, so I need the total length of the full name. If that's a scenario, then that we can achieve using the overloading this particular method, which is underscore underscore length. So this is a special method we use, and we can overload it to get our required output. Now for that thing, I'm applying a length method stating that self dot full name. So get the full name and see the number of characters it has. So I apply it, and I will let me print it here, print length emp1. So now you see we are getting the output as 9. Let us validate if it's correct or not. So let us call emp print emp dot full name function here, and let us see. Now let us calculate 1 2 3 4 5 6 7 8 9. So we have total 9 characters. The length of this particular full name is 9. So that's what we're getting it. But without overloading the length method, we were not able to get that output. So you can overload the length method, which is throwing error when you are directly applying. And after overloading it, you can use the length function on your instance method. Suppose now you would like to concatenate two different object names. Let us say now you would like to concatenate two different instances full names. That we can achieve using the add special method. So before that, let me show you that if I do emp1 plus emp2, it will give me the error. The error says unsupported operand. Now you would like to overload the plus operator here, that we can do using this particular method, special method. Now what I'm saying is, when I apply this plus operator, then I have to concatenate the first object first name and the second object first name. So here so let me execute and show it to you. So emp1 plus emp2. Now here you can see I'm getting the output. So the first object I'm passing here is self, and second, so this would be the first argument here, and this would be the second argument here. Okay, emp2 is the second argument. So self dot first, the first is Kalisa, and second is other dot first, which is Vivek. So so here we are concatenating, so we are getting the respective output. But without this overloading, if we are applying the plus operator, we were getting that error which says unsupported operand type. but after overloading it, we could able to get the required output. So this is how you can overload the special methods we available to get the required output or required behavior out of those special methods. So you can check the list of these special methods in this Python link, which I will share in the description. So here you can say you have add, subtract, multiply, math, and these are the couple of already existing special methods, which you can overload to achieve certain behavior from your class. So that's how you can use the special methods and overload it to meet your requirement for that particular class. So any questions on these special methods, you can leave a comment in the comment box and I will address those questions. So for coding exercise, please refer to the GitHub link in the description. This is the end of this particular video. So I will meet you in the next video. Till then, I am Vivek signing off. Bye bye.